Cloudflare is moving from NGINX, their primary reverse proxy and caching needs, and even web server, request handling, to their own homegrown reverse proxy. It's called Pingora. Let's jump into it and discuss. This is very, very interesting. As usual, Cloudflare is one of the very few companies that actually write detailed technical articles like this. We as engineers starve for something like this. We really like this level of details. Although admittedly, their new proxy, Pingora, they did not explain how it actually works. They give us kind of a flavor, a hint, a teaser. And boy, we really need another, a whole brand new blog just to talk about that. In this blog, they focus on the problems of NGINX, the deep architectural flaws that they saw with NGINX. Does that mean that NGINX sucks? Not at all. It does not mean that. It's just the massive, trillion request, HTTP layer 7 request that Cloudflare actually receives as a content delivery network, and as a DDoS protection, and many, many other stuff. They just run into a very unique cases that usually we don't see as, simple backend engineers, you and I, Let's get into it. So they talk about NGINX here. The main use here is for Cloudflare is when you have a website, let's say Stack Overflow, which uses, maybe they use Fastly, but let's take them as an example. When they want to cache their content, they can hire Fastly or any content delivery network, let's say Cloudflare. What Cloudflare will do is will ask Stack Overflow to point their DNS IP addresses to Cloudflare, right? And they will effectively terminate the traffic in Cloudflare and then establish the TCP connection to Cloudflare. All users will go to Cloudflare. The TLS connections and encryption will go to Cloudflare. And Cloudflare will decrypt the connection, will decrypt the request, will see every single request that the customer sent, and then turn around and look in their cache. Hey, has anybody asked for this before? Nope. All right, let me go ahead and send a request to the origin, right, which is the actual Stack Overflow origin servers, and that will basically serve them. And this is what they're trying to optimize. Right? The caching, request processing, CPU latency, request pinning, and back-end connection establishment to the origin servers. So that's what's happening right here. Again, Stack Overflow doesn't use Cloudflare. I believe they use Fastly, but I just gave them an example of a popular website. So they talk about why build another proxy. Over the years, our usage in NGINX has run up against limitations. It's always like when you use something out of the box, maybe 70% of the use cases will just fit you right nicely. But you will almost always, you're going to have a use case where this product will not fit you. And you can customize it, you can configure it, or you can end up just building your own. Right? And this is always a decision that an organization has to make. And it's a very tough one, right? So I want to talk about the architectural limitation that NGINX has that at least Cloudflare ran into. It's a very interesting thing. So in order to do that, I want to go to NGINX website. How NGINX works is it's a very simple and elegant design. They spin up what they call worker processes, an actual dedicated processes. Those guys do the actual work. There is one master process that actually spawns these child processors. And these worker processes, usually they're one-to-one with the number of cores that you have in the CPU. And whenever there is a request for a connection, what will happen is, and I have another article here that actually explained it better. What will happen here is the application will establish the connection, right? The TCP connection, and it will go to the kernel. First, we'll go to the NIC, and then from the kernel, take it there, and then the kernel will start to deliver this connection to the socket listener, right? And this is the kind of the advanced, or really the common things to do here, where each worker process, right, will have a listener socket, right? They will listen on the same port, and you might say, how is it that multiple worker processes will listen on the same port? That's an error, right? Well, you can override that with the socket option port reuse, and the kernel will just load balance these connections on each accept queue, and the worker will basically accept, right? So this way will increase the throughput, as opposed to the old model where we have a single one and all of these processes will fight over a single listen, will accept on the same shared socket file descriptor, right? And then when they all fight on that, there is a contention that will happen here, right? There is mutexes, and it's an object memory. The moment you have two people fighting over it, they will get queued. Now, whether this approach is better versus this, it's still really debatable. This is back to the concept of queues. When you go to a grocery store, for example, a grocery store, there's an option where you have one queue and you have multiple cashiers. That is identical. This is the same thing here, right? We have multiple cashiers and one queue. This can work. The problem here is like you're gonna get a very long queue, right? So naturally say, hey, let's have multiple queues, and each queue will have basically its own worker process, which is its own cashier, effectively, right? So people will line up right here, but this is also has its own limitation, right? But I don't want to go into details here, because what if this cashier, I don't know, this guy payment process failing, and he's trying, and he's giving another credit card, and all of these guys are now blocked while these guys are not doing anything. So technically, you can say in a real world, just go to another line, and people will start jumping to other lines here. But it's very hard to do in an operating system to jump between lines. Envoy actually, I believe do that. And behind the scenes, they can do something called listener balancing. But yeah, I don't want to spend a lot of time discussing this. Back to this. The architecture limitation is actually that when it's in this configuration, right? There is a chance where the request is pinned. The worker process will have many connections, right? Because the connections will be shared. So requests are sent on these connections might be greedy. Some connections might happen to have a very CPU intensive HTTP request, right? I don't know. It's doing a lot of work, or a blocking IO, right? And I can't think of an HTTP request that is actually CPU intensive in the caching layer, right? I don't know. I suppose you can have some edge workers running on Cloudflare where some, I know there's some stuff that you can do to replace the cache. Like you have version of the cache, but you cannot change it. I don't know what it's called. The service worker, is that what it's called? Service worker is something else. I don't know what I'm thinking about, right? So the problem here is there can be a request that takes a lot of CPU, and this will block the worker from doing other stuff while these guys are singing and happy and not doing anything, right? So this lack of load balancing is one of the problems that they want to solve in Cloudflare. They notice that, hey, it's like we have one worker that is so heavy, with executing stuff, but the others are just not doing anything. Yeah? The other problem is, what is really most interesting to me, is the back-end connection pooling. You see, when you make a request to NGINX or any reverse proxy, the reverse proxy's job is to turn around and talk to the actual origin server, right? That's what a reverse proxy is. And in order to do that, it needs to establish a connection to the backend, this is the true backend here, right? The server. What happens here is this is one worker, This is another worker. This is another worker. Each worker will have its own sets of connection pool that is already established to the server. What does that mean? It means that if a request came in here, that worker must use one of these connections in its pool, because these pools are isolated. Right? The processes are completely isolated. Yeah, there is some shared memory between them, but connection pools are not one of them. Okay? So if I turn around and if a request came in here and it turns around and want to talk to the server, it has to use its own connection pool. And if there isn't any connection, or one of these are busy, then it has to establish a new connection, right? Although another worker might have a connection that is already hot and ready to be used, but it cannot use them. And that's the major problem that NGINX, that Cloudflare want to solve. The repetitive handshakes and TLS handshake to the backend, which is very expensive. It's not really expensive when it comes like it's if I establish one connection in 3, 4, 10, it's not really. But if you have in hundreds of thousands connections, it really adds up. So that's exactly what they did here, right? So that's one flaw, and we're gonna come to how exactly they solved it. They only talked about how they solved that. They also talked about like the limitation of how NGINX uses processes instead of threads, and process and thread are really very similar in Linux. So I was really surprised to know that this was a limitation, I guess. But I suppose the sharing model in threads is easier, because by default, when you have a process and you specify a thread, threads and process, the main process, have some sort of a shared memory by default, right? You can, of course, control that. But if you have different processes, they each have their own dedicated memory. Yeah, you can create a shared memory. That's what Postgres does, right? It has a shared pool, and all of these guys share this memory. You can do that. The moment you do that, you have to have mutexes. You have to kind of serialize the stuff, the access. It's very interesting stuff, and this is very deep. We're going to really need to talk about this stuff here. The difficult to add features, right? When you add features, this is a problem that Google has, with Borg, started with Borg really, which is the Kubernetes, the original Kubernetes. And they started like, when you develop a software, you develop it for your needs. So, but if it's open source, you have to really abstract it, and that is really painful, dude. Because if you abstract things, then you add complexity. Because instead of just doing the thing, you have to intellectualize and think about, what else could how can I make this abstract so that anybody can use this feature? And that's what kills most, it makes software complex. Abstraction absolutely makes software complex, because now you have to kind of think about, you cannot just add this feature because it's only you. So now we have to theorize, okay, how someone else can actually use this. So now you have to, let's introduce this concept so that it can be fit in, and then it gets confusing for people. It's like, why do I need this, right? But that's part of it, right? The other part is adding features like take retry and failing over, for example, in NGINX. They have their own special logic that, okay, if I want to talk to, if a request failed, NGINX just retries the request. There is an option to retry. That doesn't work for Cloudflare. They want a custom logic for retrying. And in order to do that, like, how do you do that? How do you bake this into NGINX? You have to add configurations. You have to add code, right? I believe NGINX has this thing that's called Lua, the language, that you can extend it. I never used it. I think I used it once when I developed a game. Like I purchased this tutorial to build the games, and that's the only time I used Lua. But yeah, it's a very interesting. That's apparently a problem with Cloudflare and extending that thing. So they chose to build their own, and here's why they built their own. They had basically the problems. And they said they had, okay, we have three choices. What could we do? NGINX is a problem. What do we do? We can invest in NGINX and possibly fork it to tailor it 100% to our needs. The problem is pushing those back to upstream is just out of the question. They cannot push that because whatever they do is very sticky to their architecture, to Cloudflare's, right? But they said, okay, we're going to fork it and we're going to call it something else. But the problem here, the architectural limitation. They said, hey, this connection pool thing, the process model, the way you share memories just doesn't work for us, dude. So it just doesn't scale and it's a problem. So what do we do? They said, okay, let's use Envoy. Envoy is it's a great choice, right? And they did definitely consider it. They said, okay, let's migrate to a third-party proxy code base. We're going to completely migrate to Envoy and others. Like when you click on others, it says it's point to Linkerd. I don't know why did they call it. They didn't just say Linkerd. It's just that link. I don't know. It's just a little shady. But yeah, but this path means that the same cycle will repeat. It's like what will happen in a few years? Like what if Envoy, we hit a block with Envoy, right? And the third option is just start from scratch and build it, and that's what they picked. They said we're gonna rebuild the whole thing because the architecturally it doesn't scale, you know. And whenever you have something that is architecturally flawed, again flawed to your needs, doesn't mean NGINX is bad. Again, I have to repeat this. Right? NGINX is a great proxy, you know. And by the way, when they mention the word proxy here, they really mean reverse proxy, you know, but it's just implied here because nobody uses Cloudflare as an actual proxy. You don't go to your, I suppose never do, like you don't go to your setting and you set Cloudflare in your proxy setting, right? It's not that. It's a reverse proxy. It's the final destination to you, and then it turns around, it talks to some origin server. The Pingora project, and they used Rust, and this is where everybody really cares about. I don't really care about the language being used, to be honest. I mean, yeah, it matters, but by how much? Architecturally is what matters to me, right? The language really doesn't matter to me. Like, okay, C, Rust, okay, there is security consideration with C, and that Rust solves. That is good. It's not something interesting to me. A lot of people are very excited that Rust. I never used Rust. I know a lot of people want me to cover Rust. Maybe in the future, I'll try it out and see how is it differ. But yeah, and here they talk about like how even using Rust, you know, when you use a language, you have to use libraries that come with the language. You don't have to, but you can, right? And the first thing is like, okay, let's use the HTTP library. Definitely not an option for Cloudflare. I saw it's like, what? You're not going to use the built-in Rust library, Cloudflare? You're never going to do that. Of course, it's your bread and butter is HTTP. You cannot use a baked-in out-of-the-box HTTP library. You have to build your own. So they did. They actually built their own Rust HTTP library. Because and they explain here that the web is, it's like it's wild and there are no rules. There are rules, but not really followed. And they want this flexibility to have their own HTTP library. Because the moment you use an HTTP library, it's the same problem with NGINX, right? You cannot just request changes. Oh, we want to add this. Let's talk to the library maker and have meetings and have discussions and the worst thing ever, it's like, oh yeah, let's have a discussion, let's have a meeting, let's have a month worth of meeting so we can add one line of code. These are the worst, this design by committee things. It just takes so much time, right? Sometimes it's useful, of course, but yeah. And then they obviously moved to multi-threading over multiprocessing in order to share resources, especially connection pools, easily. The word, emphasize on the word easily here, right? Because you can do it, but it's not as easily with multiprocessing. And this is another interesting concept called work stealing. I never heard about it. Work stealing is actually as the CPU level when tasks are scheduled. you know, and CPUs can actually be configured, or I suppose the processor itself can be configured to steal work from other CPUs that has queue in them, right? And instead of sitting idle there. I don't know how it's implemented, but this is what it is effectively. So they do this as well. So even if the cores are imbalanced, you know, the one core is doing a lot of stuff and the other cores are not doing anything, I don't know who actually does that, but I suppose there is a monitor process that monitors these jobs and actually will shift, okay, hey, you're not doing anything, just take some cue from this process, and instead of actually just don't do anything, do some stuff. And now we're talking about talking across cores. This is where NOM architecture comes into the picture, and I don't know the cost of talking between cores. Yes, if you're using like M1 or M2, the new Mac CPU that actually the SoC is so tucked in with the RAM and all the cores, the cost between going to the cores instead of going to the bus is negligible. It's nothing. So they made it really, really fast. But and then this is the most important thing. This is where you're here. What did they change? That's the only thing that actually mentioned about Pingora architecture, right? That and the multi-threading, right? So again, this is not by any means a complete article. So what they did is they share all the threads share the connection pools. So even if you have a request comes in here, and instead of each request sitting in a thread and just being isolated, right, just like NGINX, and doesn't know about any other thing, no, it actually can reuse the connection pool that is just global, you know? And now, of course, you have to be careful with this, because accessing this connection pool, you have to really, still you need to be careful, two threads accessing the same connection. You cannot use, like once you have a connection to send a request, you cannot use another thread to use the same connection. You have to be careful, not two threads taking the same connection. Right? Now, this could be, it depends, right, whether the backend is HTTP2 or not, because you can do multiplexing. But this is a complex thing to discuss in a few minutes video. So maybe in the future I'll go into details, but this is really cool. You know, by reusing connection pool, they eliminated the need of establishing connections to the backend. So they went from the connection reuse went from 87 to 99.92. That's huge, really. And the connections, new connections to the origin were reduced by 160x. That's a lot. So now, here's another thing. We saved our customers and users 434 years of handshake time every day. That's a lot of handshakes. But yeah, so they talk about now here the more features. They're adding HTTP upstream. You know, they easily added that. Why do they support HTTP to upstream? That's what Envoy does, by the way. That's what they, you know, Envoy really like to talk about, that having HTTP upstream. Why? Because gRPC, and gRPC is basically the I guess the de facto right now. I know there is the Apache thrift, but now gRPC is the de facto communication when it comes to microservices and things like that. Envoy always uses, it's the de facto service mesh, right? That and also Linkerd, right? And when two services want to talk to each other, it's proxies talking to each other. So everything is almost gRPC. So now gRPC is very critical. And when your backend is behind Cloudflare, you can use gRPC. Again, this is gRPC at layer 7. Obviously, nobody's talking about that because it's always implied. gRPC at layer 4 is useless because it's just so consuming. You need to have gRPC at layer 7 so that messages sent are actually understood by the proxy and turn around, terminated, and talk to the backend. All right, guys, I'm gonna stop right here. This is This is a very lengthy article, talking about detail stuff. Still is missing a lot of juice. I want juice. Cloudflare, give us some juice about Pingora. More juice is required. Thank you so much. And I'm back. I was on vacation for a month. I went to Bahrain to visit my family, and now we're back. So videos will be resumed as usual when I had the time, of course. Take care. Goodbye.